Audio Jungle. Audio Jungle.
Hello friends, here we are going to cover numericals related to both KCL as well as KVL. Look at the question here. A segment of circuit is shown in figure. If voltage across the resistance is 5 volts and voltage across the capacitance is 4 sin 2t volt, then what will be the voltage across the inductor? So how to find the voltage across inductor here? Value of the inductance is present. To know the voltage across inductance, definitely we should know what will be the current through the inductor. To find the current through the inductor, definitely we should write the word KCL at this node. So when we write the KCL, automatically we can find the word current through the inductor. If you know the current, we can use that relation voltage across the inductor L di by dt. With that we can get the word result. Now when you write the word KCL for this node, right, 2 amperes is what incoming, that we can easily observe from the word given circuit. But what about resistance as well as capacitance? 5 ohms and voltage across the resistance is given, but RLC components means resistance, inductance, capacitance are what? Passive element. Passive element means these are absorbing the what? Power from what? Other components in the circuit, means these are taking the what? Energy. So when power is absorbed by the elements, definitely current will be what? Entering into the what? High potential, that we already discussed when we differentiate what? Active as well as what? Passive element. Active means when current is coming out of the what? That high potential, that is delivering the what? Power. When current is entering into the what? High potential, it is absorbing the power. So passive means definitely absorbing. So look at here, when resistance is there, what must be the current direction here? Based on the polarity, current must be what? Entering into this. This is what? Resistor current IR of T. Similar fashion, if you look at that capacitor, is also a what? Passive element, absorbing the what? Power. Definitely based on the polarity, what must be the what? Current. This must be the current entering into high potential. So this is our IC of T. Again, what will be the inductor current direction? Plus minus is there. Definitely this must be the direction, because it is also absorbing. Absorbing means current is entering into the high potential. Based on this simple statement, we identify the what? Directions. Now easily you can apply the word KCL for this node and you can get the what? Current through the inductor. Look at here, 2 amperes as well as what? Resistor current, both are entering at this node. As I said, KCL is what? Algebraic sum of leaving currents is 0, or sum of incoming currents is equal to sum of outgoing currents. By that you can get the what? Inductor current here. So 2 amperes resistor current, both are entering. I am writing into left hand side, right? To place IR of T, and I am writing the what? Other two currents, means capacitor current as well as inductor current, both are what? Leaving currents. So I am writing into another side, that is inductor current as well as what? Capacitor current. But our interest is to find the what? Inductor current. Look at here, what is the inductor current? Take this capacitor current into another side, that is 2 plus IR of T minus IC of T. But how to find resistor current? Resistor current means resistance value is there as well as what? What is the voltage across the resistance? 5 volts. So by using Ohm's law, how to find current? V by R means voltage across the resistance by resistance value means 5 by 5 only we get, minus how to find the capacitor current? We have the what? Capacitor voltage and capacitance value. How to find the capacitor current? We have this expression, current the capacitor IC of T is equal to C into dVc of T by dt. Use this expression to find the capacitor current. Capacitance value is how much? 1. d by dt of what is the capacitor voltage here? 4 sine 2t. Now simplify this. We can have inductor current 2 plus 1, 5 by 5 means 1 we will get, minus what is the differentiation of sine? That is cosine, but we are doing with respect to time, so 2 is also coming into that, so 4 into 2 cos 2t we will get, because sine differentiation is cosine, but we are doing with respect to time, so 2 also comes. Okay, so 2 into 4, how much we get? 8 cos 2t. Simplify further, what is the inductor current we get? 2 plus 1, 3 minus 8 cos 2t amperes. This is the inductor current. But our intention is to find the what? Inductor voltage. So what is the voltage across inductor? L di by dt, means inductor current only. So inductance value is given, look at here, 2 Henry. So 2 into d by dt of what is the inductor current? 3 minus 8 cos 2t. So differentiate with respect to time. So what will be the result we get? What is the inductor voltage we get? 2 into differentiation of 3 is what? 0. Constant differentiation is 0. Minus 8 cos 2t. You are doing with respect to time. Again cosine becomes what? Minus sine. Okay, differentiation of sine is cosine only, but cosine differentiation is what? Minus sine 2t, but you are doing with respect to t, so 2 also will come into the picture. So what will be the result we get? 2 into minus 8 into minus sine 2t, again 2 also will come into the picture. Minus minus becomes what? Plus. 8 into 2 into 2 means 8 into 4, 32. So at the end result will be what? 32 sine 2t. It is the voltage, so volts. So this is the voltage across inductor. So simply we just applied the what? KCL. KCL we applied to get the what? Inductor voltage, to have the what? Inductor current. Means when you have inductor current, then you can have the what? Inductor voltage in this way. Now look at that another question on KCL KVL. Here we need to find the values of E as well as I indicated in the what? Circuit. Observe here, E is the source voltage unknown, again I is also current delivered by the source. Both values we need to identify, but what is the given information here? Only one information given. What is that? Current through 4 ohm resistance is given as what? 2 amperes. With that information only we should find what? These two values. Here we simply write only KCL KVL. With that only we get the result. Observe carefully how we get the what? Result. So here current through 4 ohms is given as what? 2 ampere. So that what will be the voltage here? 4 into 2, 8 volts, simple, by using Ohm's law. Again, if you notice current is entering in this fashion, so what must be the polarity? Resistor means passive element, so current flows from positive to negative, but it is entering into positive terminal, that is high potential, because it is absorbing. So this must be the what? Polarity. Okay, so now if you observe here it forms a what? Closed path, closed loop. I don't know what is that. Okay, voltage across 1 ohm resistance, I am assuming V. Got the point? So here in between 4 ohms and 1 ohm we have a closed path, so I am making a closed path. Understood? Then if I apply the what? KVL here, current entering into negative terminal, so minus 8. Current entering into positive terminal, plus V is equal to 0. So V is equal to 8 volts. So by KVL we noticed current through this 1 ohm resistance. How much? How we know the current? Because we already obtained the what? Voltage 8 volts by using KVL. If it is 8 volts, what must be the current? 8 by 1 ohm means 8 amperes. This is the word current. Okay, you might even notice because both elements are connected in parallel means voltage must be same, but even before going with that equivalent series parallel combination, only based on the loop connection by applying the KVL we got the result here. You can even directly say that both resistors having parallel combination in same voltage will be there. Now coming to this another branch. Okay, after having current in these two branches, what must be the current here? If you just write the word KCL at this node, okay, current through this 4 ohms already there 2 amperes, and current through this 1 ohm we got 8 amperes. So what must be the current here by KCL? Okay, by KCL, what you can say, algebraic sum of leaving currents is 0, or sum of incoming currents must be equal to sum of outgoing currents. So if it is 2 and 8 both are outgoing branches, so sum will be how much? 8 plus 2, 10 amperes must be incoming, then only KCL is satisfied. So here what must be the current here by KCL? 10 amperes. And one more thing, it is a resistor. Based on the direction, what must be the polarity here? This must be the polarity because it is a passive element, current entering into the high potential. So now 10 amperes 1 ohm means what must be the voltage? This is our 10 volts. Why I am writing 10 volts, 8 volts like this? Because after having voltage across 1 ohm and 4 ohms, you can identify what is the voltage across this 6 ohm. Okay, because it is also making a loop or a closed path. KVL we can apply for any closed path, so automatically when you have these voltages you can find this voltage across 6 ohm. Now again I am just following with the closed loop action. So here again I am writing KVL for this middle portion, that is middle loop. Okay, now current entering into negative terminal. So I don't know this voltage, I am just writing voltage across 6 ohm like this. Question mark I am placing for this. So current entering into negative terminal, so minus V 6 ohms. Okay, current entering into positive terminal plus 10, current entering into positive, so plus 8 is equal to 0. So what is the voltage across 6 ohm? If you write into another side 10 plus 8, 18 volts is the what voltage across 6 ohm resistance. But after having voltage 18 volts by 6 ohms means what must be the current by Ohm's law? 18 by 6 means it must be 3 ampere. Okay, now already we have a branch current, okay, 10 amperes with the previous KCL application at this node. Now we got these two branch currents, so what must be the current I entering at this node? Similar fashion by KCL, okay, by KCL, outgoing current is how much here? 10 as well as 3, both are outcoming, so 10 plus 3, 13 must be what? Incoming current. So I is equal to how much here? 13 ampere. We got one parameter. Now if it is 13 ampere, based on this direction, 13 into 1 means 13 volts only. This must be the word polarity, 13 volts. Now again another parameter E we need to find. Here also it is making a loop. Look at here. We already got voltage across 6 ohm, that is 18 volts. And now we got voltage across 1 ohm, 13 volts. So if you write the word KVL for this loop, where source, that is unknown voltage, is present, so current entering into this negative terminal, follow with this direction based on this red color mark. Okay, follow with this clockwise direction, entering into this what negative sign, so minus E. Again here entering into positive sign plus 13, entering into again positive sign plus 18, which is equal to 0. So E is equal to 13 plus 18 means 31 volts. Now we got both unknown parameters, E as well as I. Both we identified simply writing what? Both KCL, KVL only. Okay. See another question related to KVL here. Observe, in this network we need to find the value of E. E is what? Unknown battery source, you can even consider. If you just observe this network, What is the observation here? Left hand side, if you see, V1, V2 indicated. So V1, V2 values are also not specified. So these are all unknown. Okay, V1, V2. And again E is unknown, but E we need to find. But when you just look into the right hand side portion, if you observe 0 as well as 10, both are indicated, means known values, so that you can follow with the right hand side portion to have the word information, right? You can find the word voltage E by using right hand side portion. If 0 volts is there, okay, 0 volts, and next look at here, this is what 10 volts, means what will be the potential difference between 10 and 0? 10 only. Potential difference between 10 and 0 is what? 10. Here potential difference is how much? 10 volts. Here how much? 5. Here unknown E, this is 1 volt, means I am identifying the polarity here based on the length. Low potential means small line, high potential like length is more, like that we have the representation. Now just look into that voltages and follow with this closed path. Automatically you can get the result, and just choosing direction randomly, there is no restriction. You can even take the direction in opposite manner, but result will be same. Now if you just follow with this direction, current entering into what? Negative terminal. So I am placing what? Negative sign. I am writing what? KVL, because we identified the word closed path in the right hand side, because known values are mentioned here, unknown, so we are not choosing left hand side, that we already indicated. Now when you just follow with this minus 10, because current entering into what? Negative terminal, again current entering into negative terminal, so minus 5. Current entering into what? Negative terminal, minus E, which is unknown. Current entering into what? Minus terminal, that is what? Minus 1, which is equal to 0. All the voltages we covered in the closed path. Our intention is to find what? Unknown voltage E. E is equal to how much here? E, if you take into other side, 10, 5, 1 means 16, but sign is what? Negative, minus 16 volts, because of this what? Indication. Right? This is the answer. ఏం చెప్పాలి? ఏమని చెప్పాలి?
ఫైండ్ అవుట్ చేయబా V1 నాకు అర్థమయ్యేటట్టు.
ఎందుకు?
కట్ చేయాలా?
ఇది తీసుకొని చెప్పాలి మళ్ళీ.
చెప్పా తీసుకొని V1 వస్తుంది, ఇక్కడ తీసుకుంటే V2 వస్తుంది. ఓకే, కాన్సెప్ట్ నాకు అర్థం కావాలి క్లియర్గా. కంటిన్యూ అవుతుందిలే, ఇంకా కట్ చేయొచ్చు.
Okay, additional to this, okay, here already we got the result which is unknown, but additional to this V1, V2 also you can find. So what portions we need to take to get the values of V1, V2? Observe here, V1 is what indicated here, like you can take positive sign, and here it is what 0 if you count right, a low potential. So now difference is how much here? V1. Here it is 0, and here it is what? V1. Now here how much we get? Positive, negative, negative, positive. Follow with any direction here. Suppose if I am following with this direction. Now I am writing for that V1 portion, same KVL I am writing. Current entering into what? Negative terminal, that is minus V1, right? Next plus 6, because current entering into what? Positive terminal, plus 6 I am writing. Again current entering into what? Negative terminal, so minus 1, which is equal to 0. V1 if you take other side, okay, V1 is equal to 6 minus 1, how much we get? 5 volts, right? Similar fashion, if you just look at that bottom side, okay, if you look into that bottom side here, V2, and here it is what? 4 volts is there, so I am following with this polarity based on the given representation. I am just choosing in this fashion, right? If I follow with this is what? Having 10 volts, and this is what? V2. So V2, if I imagine more voltage than this, plus minus what is the potential difference here? V2 minus 10 is the what potential difference here, and this is what 4 and 5. Just follow with this closed path, then you can have the what V2 here. So here if I am following with this direction, current entering into negative terminal, so minus of minus sign is coming because I choose this direction. Minus of what is the difference here? Difference is what? V2 minus 10. This is the voltage. Now if you follow with this, minus sign is there, so minus 4 we will get. Next again plus sign is there, so plus 5 we will get. Simplify this, minus V2, you take this V2 into another side, okay. Minus of minus becomes what? Plus 10, plus 10 plus 5, 15 minus 4 means we will get what? 11 volts. Okay, in this way just we applied the word KVL to find the values of unknown voltages. But question is to find unknown voltage E, but we even did what additional calculation which are what unknown here. You may ask, sir, why don't you find V1, V2, then use left hand side? Same way you can get, but these are time consuming, because to get the E, first I need to solve V1, V2, then again left